want to thank you all on behalf of AUSA and Quad A, which I'm kind of a Quad A guru here, is for y'all taking the time to share your thoughts today. We're going to do the panel a little bit different. General Swan mentioned we are the last thing before lunch. We understand that and recognize that, so we'll be brief. We'll get Bill to cut his answers a little bit shorter because he likes to pontificate. But we're going to do this a little different. Rather than giving you 15 minutes from each of us on our thoughts about teaming, we're going to set this up more to be questions and answers, because you're here to try and pique your interest and their interest with your questions. So we've come together with a few questions we'll start off with, but then we're hopeful that you will challenge the panel with your thoughts and ideas about the future and the teaming environment that we're going into. Before we get started, let me introduce the crew. Dr. Bill Lewis, I think, really doesn't need any introduction. Bill's been around since Christ was a corporal, and I think we go back a long ways. Yes, but thanks for being here, Bill. I appreciate it. Y'all know he's now a member. He's at the RDAC, but now a member of Futures Command, correct?
Not yet.
It's kind of shit. It's moving. It's moving. Mr. Pat Mason, who's the Deputy PEO for Aviation. And Pat, thanks for being here. As y'all know, a long-time aviator and big supporter of Army aviation. Tom von Eschenbach, Mr. C. did from Fort Rucker. Tom, thanks for coming up and sparking the conversation, a very pensive gentleman that will help us with our questions. Walt Davis, my battle buddy on the Quad A board, and from Cypress, thanks for being here. Chris Van Buiten from Sikorsky Innovations, and appreciate you being here, Chris. And Wayne, who I just met from Textron, and Wayne, thanks for being here, and he's brought some good ideas and thoughts, I think, to challenge us as we spark through this. So again, I encourage you to send up questions, or if we run out of questions, stand up, raise your hand, we'll recognize you and ask out. I'm going to start out with a few that I prepared on the Metro this morning. No, I'm kidding. And I think, Tom, since you're kind of in the middle, we'll start with you. What changes are required from a requirements, technological, and policy perspective in order to introduce autonomy and advanced teaming capabilities to both current and future platforms? That goes kind of in line with a lot of things that General Gaylor and his panel were talking about.
Yes, sir. So I think one of the things that we have really thought hard about from the requirements, and I think it spills over in the policy, is as we think about how fast technology evolves and how quickly we have to then integrate new technologies, is how do you think about a procurement strategy? If we think about our munitions now, you can't just snap the chalk line on a requirements strategy and buy 20,000 of something, because by the time you end up getting what you thought you needed, technology has changed so many times over then that you're really not buying relevancy. So I think in the future's kind of construct, it's a great opportunity to do things differently. And I'll use an example that we're really looking hard at, something we refer to as air-launched effects, is if we define a requirement, then how do we pursue the fielding of that technology that's relevant today? How do you train it today, knowing that maybe in 3 years, you're going to have to spiral in another technology that could then change the way you train it. So I think I don't have an answer to that question. I think that was one that I posed. It's something we're going to really have to think hard about. I think certainly General Gaylor mentioned it. One way that you would do that is through the synthetic training environment, where you could quickly change things. But we're going to have to really, really, I think, change the way we train, acquire, and do those things to get those capabilities.
Well, I think that's a great answer. The question poses, as you think about teaming with industry, and industry's looking into their crystal ball and anticipating what the Army needs, and the Army is so large that and it takes so long to buy and train and field things. I think as we look to the future, we need to acknowledge that we're going to have different capabilities at different times, and then by the time you finish fielding this capability, it's kind of like the roads in Atlanta. By the time they're fixing the potholes on one end, they start on the other end and go back through again. So it's going to be a dynamic, continuous change. So how we do that, and I think teaming with industry and anticipating that's going to be key. Anybody else want to jump on that one?
Yeah, can I just pile in on that? I think we're coming up on a really interesting challenge in how to certify or qualify the autonomy in these systems. And when we talk about teaming between, we were just talking about autonomous to autonomous systems, manned to autonomous, very challenging, new, stretching qualification requirement and process. And I think we're going to come up on that very quickly. I think there is a path through it. We just all need to acknowledge we really haven't done that yet.
Wayne?
Yeah, if I could, one other thing is in terms of policy and planning and budget cycle planning, the term obsolescence often is looked at as a dirty word because it's you failed to maybe keep up. But if we look at technology and the state of which we're injecting new capabilities, to your point, like the road construction, it's a never-ending activity. We need to plan from the beginning that it's going to continue, especially if we continue to leverage, commercial technologies and stay the pace there. So I'd challenge that we need to plan for that as we move forward.
Fundamentally, it's a different way of thinking, because when we acquire things and we tend to believe we have to provision the entire Army, the entire fleet, and the way we do things now and look to the future, we may only provision a certain portion, anticipating that capability is going to change at some point. And that's a fundamentally different way of thinking than how we think now.
Absolutely.
Yeah, let me hit this one. I don't think technology is a pacing item. I think Chris hit it a little bit with qualification, but the whole infrastructure is a pacing item. When you talk about commander's intent, think about this. Give me some flexibility. How is the commander's intent influenced when I have AI systems that, once deployed, are making deliberate decisions about what they need to do? So the decision for the commander is what? To employ those systems and allow the algorithms to work? And how does that affect commander's intent on a continuum? That kind of infrastructure, when you bring them back home, how do you train those? Because nobody's going to let you do that in airspace, right? They're not qualified, and who knows the bounded solutions that they have. So those kinds of policies, I think, when you start talking about, the whole doctrine piece, has to have a large amount of flexibility in it to be able to handle the rapid pace of innovation and technology.
Yeah, and if I could, just from really a procurement perspective, right? So you get a requirement and then we take it through to deliver a capability at the end. I really wanted to go back. Tom touched on it briefly in creating that requirement, but I'll go back to what General Mangum said in the last panel, which is not buying stuff, but capability. So as you look at the capabilities that Dr. Lewis just talked about, what Colonel von Eschenbach talked about, those are cross-cutting, and what we tend to do when we write a requirement is we write a requirement for a platform because that is what we are comfortable with. That is the way we budget, and we look at what's on an Apache or a Black Hawk or a Chinook, where we have an air-launched effect that we want manifested in a capability in the field. And so what we've been working with Fort Rucker on, in conjunction with the S&T community, is how we craft requirements that are more overarching, that apply more to that system construct, and then we look at how we model that behavior. And that's a fundamental shift in the way that we would deal with industry and flowing that out as well. Because instead of going out and saying, I want you to build me this thing, I'm looking for you to, and to Dr. Lewis's point, potentially build me a cognitive architecture, which we're not really sure how to evaluate that right now, to Chris's point that he made. But we understand that cognitive architecture would flow across multiple different aspects of a system of systems construct within multi-domain operations. And so the requirements got to flow down in that manner as opposed to what we typically do, which is at that platform basis, and then how the infrastructure is there to support it throughout the acquisition cycle, through delivery of that capability, and then how it transitions into sustainment.
I think, Pat, that's a great point. In my old life, I used to put up that acquisition chart that looked like worms and maggots eating things. We got things, I told the people, we got things done in spite of that process, not because of it. So I think what Pat's talking about is so key as we think about how do we incentivize industry to keep us where we're actively managing obsolescence. And right now we do a contract and it's a deliverable and we do procedurals and we do all of those things. how do we incentivize our industry partners to keep us relevant? We need to contract, and we need to go for, just like General Mangum said, the capability. We need to contract for a capability that incentivizes industry to keep you relevant. And that's the challenge we're all facing. Okay, let's move on to the next one. Walt, you being in your role here in D.C., you understand all this lingo, so I'm going to give it to you hard. Given so many competing priorities within the aviation portfolio, is it apparent that our current funding profile and funded manned-unmanned teaming initiatives are going to be sufficient to advance the desired capability as we envision? Again, there's that capability word.
So I'm going to start by saying I agree with everything that General Thurman said first before I continue on with this one. No, I mean, we're in a very challenging time right now with respect to our aspirations, as we've kind of described what we envision as unmanned teaming and advanced teaming, which does involve two platforms. In General Brito's, portfolio, it involves your robotics and autonomous systems, so you've got a challenge there as well in terms of that. And so, as General Thurman said, we shouldn't apologize, but it is costly what it is that we are getting ready to try to do. There's no question that, as we look at the services S&T kind of portfolio and their plan and their roadmap, that there's certainly been an alignment of the desire for certain, capabilities to be looked at first, and how that translates into what it is that we think we want on a platform. But Steve Munt said it true. In 2024, there'll be a reckoning in terms of bill payers to pay for our priorities, and our priorities absolutely include the teaming aspect that we're going to have to address. And so I think certainly the priorities are set. Certainly there has been a realignment and then an alignment of our funding to address those things, and we've kind of culled out those that we don't really think are going to contribute to an end state that we've aspired to with respect to the capabilities that we want the platforms to have. So very challenging environment for sure to do that.
All right, so let me add to that. So honestly, I think there's an opportunity when you think about funding, and not to take it from the perspective of what we don't have, but from what we do have. And I think, reading, there was a recent article about, let's not go invent the new thing. Let's take what's out there at the market today, and then really the task is, how do you integrate it? So I'll use an example of things that we're looking at on air-launched effects. There's nothing new that needs to be invented to employ a smaller, more autonomous ability to employ effects via payloads and network that on the battlefield today. That doesn't need to be invented. That is, those technologies and those capabilities exist. I think the trick is, how do you now converge those capabilities and bring it together? And now you're going to ask, well, is it a program manager? Is it a program? How do you manage it? How do you spiral in new capabilities over time? How does it contracted? And that's where we're in our own way there. I mean, there's the only people that are preventing us from doing that is ourselves. And again, I go back to the optimism of Futures Command, and as General Thurman said, let's pile on. Let's pile on that opportunity to do things differently, do them better, and put capability in the hands of somebody tomorrow rather than 8 years from now. So yes, there's always going to be a budgetary kind of constraint to it, but I think there's opportunities, and let's not make it a $1 million capability. Let's make it a $50,000 or $100,000 capability that's just as effective, and then you can have a multiplying effect of that on the battlefield.
If I could add real quick to that, it's not even just looking at what's available on the market that you don't yet have, but what do you have in the inventory of your force today? So, for example, there's the OSRVT system. There's over 4,000 of those out today. That's in support of dismounted users. JLTV program did a great thing, wrote a requirement to have that as a capability set as part of it. So sometimes we just need to go execute and exercise the requirements that we put in place today. That would give you immediate capability with Apaches, JLTVs, dismounted troops to share all information And that's even before you insert unmanned systems to start to push the thread. So there's a lot of capability sets, capability that exists today that if we just look at how to employ that better, I think we can learn, we can inform the material solution for the future and have an immediate impact. So.
Next one. Pat, go ahead, please.
I was just going to comment real quickly because, what we're being asked to do is be agile, but then there's the scale factor. So you want to be agile at scale, which adds a degree of complexity beyond just being agile. So when you look at special operations aviation, given the size of them, there's an ability to be agile because of the scale and the dollar figure that's associated with doing that within their scale versus the scale of Army aviation. And so, when we look at trying to be agile, adapting systems that go on, then what I always look at is what is really the basis of issue that you want to go to, because that will ultimately determine whether or not you're going to have budget flexibility in other areas. So I can draw down the price, we can incentivize competition, we can work very closely with industry to get the best price point we have, but then how many can you afford to field? But then back to Colonel von Eschenbach's topic that he talked about earlier is if the cycle of technology is so fast, and I only want to do a 5-year procurement on that, I want to immediately go back in and recompete for the next tranche of capability that would come back out, which is a little bit more of a software-centric approach where I have hardware that I can upgrade if I need more processing capability. And so that creates an agile framework to operate within, but you have to understand you're not going to all have the same kit because you can't do that at scale because of the length of time. And certainly General Gaylor talked about that in the last panel in his comments.
I would add, and not to take too much of a hardware perspective view of it, when we do the trades on future vertical lift, whether it's medium or light, when you roll up all the requirements, the and, the vehicles are too large. We'd all like them to be smaller, more affordable. If we can fully exploit teaming and say that some of the burden is going to be carried on other assets, that it doesn't have to be as survivable because the end effector is going to be an air-launched UAS that's going to take it the final 50 clicks. Things like that can really take cost out of the system. And as we've talked about earlier, multiplying that by thousands of systems makes a big difference. So I think there's a really exciting opportunity in front of us to design a system, think FARA and next-gen UAS together to reduce the overall costs.
Add just quickly onto that before we jump to the next question is the biggest challenge of that dynamic change, always making the change and updating, is to General Gaylor and General Gabriel. How do you train that? How do you that dynamic training, and how do you sustain? And what do you tell industry? I'm only going to buy 500 of these instead of 5,000, and all of that goes into that equation, into that to come out and make sausage. So those are not. I don't have answers. I'm just saying those are challenges we have to confront as we go forward. Okay, next question. Chris, you get this one. This is one of those deep ones. That's why you get it. There is machine-to-machine teaming. There is human-to-machine teaming. One major focus area when we talk about human-machine teaming is the psychological one. Can you share your perspective on how we build trust between the human and the human operator and the machines? Simply, why should we trust machines to do the jobs of humans?
Yeah, I think this dovetails right in with that whole qualification issue. How are we going to qualify these systems that are empowered to take on greater and greater roles? We've had an interesting example, and to me, the foundation of it is earning trust. And you can go a long way by doing software qualification and creating a system engineered basis in the system integration lab. But the end user, that's not how they function, right? The set of test reports is not going to satisfy them. We've had an interesting experience with the U.S. Air Force, right? You have the white scarf gang, the fighter pilot with the scarf around their neck saying, I'll be damned if I'm giving up my scarf to a supercomputer. I don't trust it, I don't want it, and I like my job. So we put in a auto collision avoidance system in the F-16. We said, yep, you're right. But F-16, there's a system in there that when you black out in the mountain pass, you pass out, hypoxia, whatever it is, pull too many G's, you're going to come to stabilized flight above terrain, and the computer's going to ask you, do you feel all right to take over? Right? So it only took about 6 saves for that pilot community to go, oh, heck yeah, I need that on my airplane. And, you know, it's those 6 guys, they told 2 friends, they told 2 friends, they all saw the video, and then immediately, right, you started to build trust, and the question immediately pivoted to, what else can you do for me? So I think these solutions that are kind of a big bang approach, probably not the right path, but spiraling in this capability is a way of earning and growing trust. You're seeing the same thing in the automotive industry. Probably not the big bang, but you get used to the lane detection, you get used to ABS braking, and you can't live without this stuff. So now that Air Force community, the next killer app for them is Deathclaw targeting system that makes the gun much more lethal than it previously was. And that was only possible because we started to earn their trust. So in front of us is obviously the deep system engineering, qual, hard work, but also a introduction mechanism that builds trust with the operator.
Yeah, I would just add, I mean, trust and autonomy is going to be a challenge as we move forward, and there is a huge psychological component to it in aviation psychology. And that's why, you know, as Dr. Lewis said earlier, not a technology problem, but it's more of the infrastructure, but also the psychology behind it, and then earning that trust. I will go back and, you know, we've got a panel coming up after this that talks about live virtual constructive for training. But when you look at the complexity of autonomy and the fact that it's non-deterministic in some cases, right? I'm not going to get the same answer every single time. And what we look at is a need for an integrated live virtual constructive environment for the assessment of these autonomous functions, or as you look at teaming when that system of systems is large. Because we do a really good job of evaluating one system against another system, right? That's the way we do our interoperability testing right now. But we're looking at one system operating within an ecosystem that has large scale, large behaviors that are in there, behaviors that can change. And doing those sorts of things are necessary not just to certify the system so that we can bound the behavior of it, but also working to ensure aviators, soldiers have trust in the answers that they're receiving. Trust in that the system is cognitively processing things in the way that they want it to result in, things that they can action from it. And so that requires a shift from it, which also requires a shift in the way that we test, because you can't test any of that stuff by just going out to the field. It's unaffordable to go do that system of systems level integration. But that's another use of live virtual constructive and really nested into how we're thinking about trust and autonomy and system qualification.
Yeah.
Hey, sir, let me,
Go, you want to go, Tom?
let me just say something real fast and kind of take that in a slightly different direction. So when you look at the system view of autonomy, you know, certainly you get into a conversation about the human trust in the machine and that psychological barrier there. But I will tell you, running through some simulations and kind of experimenting on how we would do this, and you look at the operational view, I will tell you it was really kind of a deep thought of when you add autonomy, when you add AI, and you quicken the pace of decision, which is really what we want to do, right? We don't want to take things away from a human. We want to enable humans to be faster, more agile, and make the decisions inside somebody else's decision cycle. But when you do that, it realizes that now the burden is on the commander to make the right decision at the right time that has to look out farther, because now as you think about standoff and effects and times of flight and stuff, you no longer have the luxury of having your own sensor, your own organic platform to shoot. It's often something else sensing way outside of your ability and something shooting back here, that the time frame is so different too. And that was a kind of a, when we saw that, we were like, wow, you know, the commanders are really going to have to be on it to make a decision really fast. And I guess I would equate it to, you know, using a football analogy. If you're going to run a fast-paced, no-huddle offense and look at all these signs and do things really fast, you're either going to look like a hero when you score fast, or you're going to look like a zero when you go 3 and out and you've only burned 20 seconds, right? So I think that kind of thought has made us think, wow, it's not just machines, it's actually commanders making decisions at that speed also.
That was really quick, Tom. I think it's going to be incremental. It's going to go from bounded solutions to unbounded solutions as we go to AI. It'll go from prescribed maneuvers to autonomous maneuvers. But it's not going to be about us. And the people that are going to be living these systems are going to be far more trusting than we are of autonomy. They've grown up with autonomy. They're going to see more and more autonomy. I mean, my 57 Ford did not have a anti-lock braking system on it, you know. Now everybody's got that, you know. So I think that's the way we'll work through these systems. But the next generation's not going to have these problems that we have.
I think that's a great point. I'm known for my gross oversimplifications, but I think about 25 years ago, who would have got on a train at the Atlanta airport with nobody driving? I mean, we're getting there. Next one, Wayne, on the end, let's let you dive on this one. What technology enablers are you working on to allow for the necessary advances in teaming to occur in the near, mid, and long terms? It's kind of an open-ender there.
Yeah, I think it dovetails very well into the conversation that kind of just bloomed. You know, Textron, industry in general, I think we all agree it's not going to be a big bang. Obviously we maintain focus on extending capabilities of current systems, increasing the level of interoperability, the level of teaming with the systems we have today, because they're going to be around until the mid-2030s, right? But while we do that, there are enablers that we have to invest in to take that next step and then ultimately to allow it to continue. So as we move from a one-to-one situation right now with unmanned systems, you start to get into a one-to-many. You start to enable the concept of having, you know, as it's been described, you know, 11 Bravo operate the system at the forward edge. You have to get into a multi-platform command and control scenario where you have a rated pilot in command that's monitoring and managing basically assets he's handing out to somebody else to go use. And as you do that, you have to make the system more intuitive. Not only intuitive for that pilot in command to manage the health and status, but also now for that forward operator to worry about the effects that they need to put on the target. So that's certainly an area that we're focusing on. From the platform side, we're certainly exploring the areas of energy and more agile systems. Quickly, I'd like to pivot to autonomy. Right, that is autonomy, machine learning, AI is a very, very large, undefined vernacular. And what we're really focusing on kind of aligns to what not only is in the realm of possible, but what's in the realm of what are you going to allow? Because we can certainly invent and provide a fully autonomous system that you can speak to, give it a generic system, and let it go out. But if policy and rules of law and warfare won't allow it, we're really focusing on mission behaviors. So how can we, I guess to Dr. Lewis's point, in a more confined or bounded environment, help the system be smarter in that operation? So we're investing in abilities to provide specific behaviors in a mission construct, whether it's a strike mission, an ISR mission. You know, we have some activities with our Navy brethren on a cooperative research and development agreement there to do collision avoidance and certain mission sets there. So that's really the specific area that we're focusing on is mission behaviors and autonomous actions within a bounded area.
Thank you. I think Tom kind of hit on it also as well. As anything we can do, we're still going to have a human in the loop. Anything we can do to take the burden off of them of the things that can be done with these autonomous solutions, where the decision maker then has more time to focus on those split-second decisions they need to make. That's kind of the focus. Okay, next one is Dr. Lewis. Okay. How do you envision the implementation of the UAS/ALE fleet?
When I talk about this, it's a tiered, layered system. We'll have a lot of close assets. We'll have assets that are 70 clicks. We'll have assets that are 150 clicks. and they'll be at different altitudes. I talked to General Rugen. He talks about systems that are forward of the flot and doing things. I'm not as optimistic there. I mean, I think we will eventually get to that point, but I see it being implemented more in that tiered, layered approach. And in that approach, you're able to communicate, you're able to cooperatively perform missions of all sorts of things that you can't do today. Again, it's back to that capability. But I'll say this, and I'll talk. You know, I know the networks out there is like a big thing, but my philosophy on that, kind of like back to fundamentals for General Thurman. It's my opinion that if you want a network when you get on the battlefield, you better bring that sucker with you, because I'm not sure it's going to be working as well as we think it might be with all the chaos and cyber and all those other things that are going on. So what does that near net look like, and how do we interoperate with our tiered layer system on that near net?
Anybody else want to jump on?
Yeah, I would just add to that, when you do the trades of teaming in these congested communication environments, contested environments, you've got to send very simple answers in small amounts of data, which does push a lot of processing on board each node. You can't just send out the data stream and have someone else collect it and digest it and understand it. So that's the bad news, is you need a lot of computation in each of the nodes just to send out very discrete answers and solutions instead of chunks of data. The good news is the processing is quickly becoming available to make that small and affordable and get that degree of processing on board.
Okay, great, thanks. Pat, I guess we don't want you to feel left out here.
Oh, I was
Are
going
you going to jump on that one? Go ahead.
Yeah, I was just, because to Chris's point, you've got to push a lot of computational power forward, because you've got to send short bursts of data back. And then an air vehicle or some air-launched effect would have some type of behavior that it needs to do when it had lost link or lost comms and what you want it to go do. All those have to be factored in. The challenge, and this is really to industry, is what you often see is an industry solution. So they will come with a solution that is complete from air vehicle through the cognitive processing as well as algorithms that would be hosted. Our challenge when we look at it is those algorithms may apply to multiple different air platforms, multiple different air-launched effects where we want to host those same algorithms. And so as we look at decomposing how we would, again, procure that, then how do we flow out what we want from an algorithm perspective, and then what needs to be hosted on an air vehicle, so that we can reuse that set of algorithms that has been developed. We can ensure the intellectual property is retained in that, because that's probably where the secret sauce is, where industry wants to retain those algorithms, but we put it into a host environment on an air vehicle where we can cycle that as algorithms are upgraded. We'll have a different vendor that could potentially do the backplane that's there. And this gets to what General Gaylor talked about earlier, which is the concept of the open system. Right? It doesn't mean that everything is open, but in the case of those algorithms, I need to have the ability to host those algorithms on multiple different platforms, not all made by the same OEM.
As Chris mentioned, the processing power is quickly advancing to get us to that. But there's also, we got to recognize there's multiple users of the data. And the data is going to have to be prioritized and where it goes to make sure that the guy or gal on the pointy end gets the critical data that they need, and we're not consolidating data that could be downloaded tomorrow. Please.
I talked about this tiered layered system. I didn't want everybody to think that it was just, everybody talking to everybody. We talked about IADS all the time. We talked about the integrated air defense system, and we've kind of taken that for granted now. But when we take a look at offensive and defensive operations, movement to contact, whatever it is you're doing, that has to be a very integrated activity with all of the systems that you have out there. We talked about 1v many. It's on demand. It's whatever sees something is going to be communicating that information. And that integrated, if you take a look at a movement to contact, maybe it's just like a big tunnel looking thing on a chart that says everything within this is integrated, and there's probably some connectivity, those crossing fires that we talked about earlier. But we have not, I don't believe as an Army, really thought about the execution details of what an integrated force of that nature in those kind of operational scenarios really means. And it's all about the details. It's all about how am I supporting the soldier that's in the foxhole? You know, how am I doing all of the things that I need to do for fires? You know, is every one of those things a repeater? To Chris's point, I mean, we did autonomous dual lift, and we found out that we could keep relative position of the aircraft at a baud rate of about 1 second at 5 kilobits. Bits, not bytes, bits. You know, that's a small data package. So you've got to do the kind of research that allows you to say, yeah, we know what we could do, but what's the minimum amount that needs to be done to accomplish these things? Because throughput's going to be problematic in any of these kind of capabilities we're talking about. And then again, back to the net, you know, we're really dependent upon the net.
Okay, thanks. Now, Pat, we'll get you your first question. From an acquisition programmatic perspective, what changes are necessary and what are some of the critical challenges as you transition S&T efforts in autonomy and advanced teaming into fielded capabilities? A lot of what we've been talking about, but this kind of specifically hits on it.
Yeah, so you know, that's kind of the age-old question, is how do you successfully transition S&T across the valley of death and then get it into a program of record that delivers a capability? And we've been struggling with that we've been discussing that on panels well before I was probably out of college. They were talking about that, right? I will say with the Army's focus on how we transition from 6.2, 6.3 applied technologies prototyping, it has created greater integration across the acquisition framework right now. And again, that's one of the key words today. In fact, to General Brito's point on your slide, synchronization isn't good enough. Continuous integration is essential, right? So the mechanism or the architecture on the back side of the house has to be in place so that we understand exactly what's coming in the S&T world and how we inherit that and can turn it into a program of record. With General Rugen and the CFT working on that, we've been able to communicate effectively on what we need to inherit. But I will say that once we inherit those items, and I'll say that because that could be in knowledge or it can be in a system, the question is, how do you move it through when you look at advanced teaming? And I'll start back to where I began with the requirements. So in the requirements process, understanding how the requirement flows really from behaviors, which is what Wayne talked about, how those behaviors are manifested across multiple different systems or platforms, and then how we decompose those down and determine our trade space is going to be critical, because that will give us a determination of what is good enough. Understanding what is good enough, then we really, because of the complexity of these systems, have to go into a digital acquisition framework. And what I mean by that is we are working together on how we model this, and the intent is that as we move forward for some of these things, we will provide industry a model in an RFP that you will propose against, as opposed to paper, which is what we have habitually done. In fact, even today, we flow complex interfaces in reams and reams of paper back and forth. And again, they're digits, but you've got to read what's there as opposed to being able to build a model and then allowing us to evaluate that and then making determinations of it. That would allow us to decompose some of the mission systems from platform architecture, which has much longer lifespan than the mission architecture that's associated with it. It would give us greater clarity in the way that we could evaluate risk and cost as we go through and then baseline our schedules associated with it. And then lastly is on the contract side of the house. So the AE and everyone have been working very diligently to make sure that we have the right authorities, whether it's Section 804 or Section 806. We've got other transactional authority that's out there as well. So we are working with the Army Contracting Command in how to collapse policy that would allow us to move more rapidly through these simplified acquisitions, particularly when you've got a high spiral of the technology time. But the key to any of that is really understanding what we want out of it. And that gets to data rights and how you would sustain it. Because you still come back to, and I'm going to speak in the acquisition code of sections L, M, and H, right? I can pick lots of different contract strategies, but ultimately you want to know how is the acquisition going to be run, what is the evaluation criteria, and what are the special clauses that we want in there. So we have ways to accelerate the acquisition process, but we have to be very clear across the aviation community on exactly what we want as deliverables from that as we move through with speed, because we do have to sustain, or we may need to integrate with other systems, and we've got to have the right clauses in there to get the right information.
And I would suggest that as you go forward and do that, one of the big challenges we have is we get the data within the government to manage and become the configuration manager. Fundamentally, we need to change how we align and manage the programs, because that transition, General Gabriel doesn't get the funding he needs to sustain an engineering capability over the life cycle for this kind of dynamic change. So that how we manage that's going to be a challenge, and we got to get the funding aligned to give him that ammunition.
Yeah, that's just to General Crosby's point. I mean, funding comes down typically within a PE associated with a platform, but in many cases it's a cross-cutting capability, and so how that flows down and then how the sustainment trail flows down. I think that's why if you look at the PEO strategic plan, General Todd's vision is an integrated, aligned, and operationalized PEO, because he clearly understands that from a PEO perspective, it has to be integrated across all of the domains within the PEO to successfully manage the types of things we'll have to take on, specifically some of the configuration responsibilities.
Yeah, I got to jump in here. As we look at this from a CFT perspective, we talk about delivering something at milestone B, and I've been insistent upon we can't deliver something at milestone B. That was broken, and we, to the point, we have to change our whole thought process about how S&T, early development, and acquisition all kind of fit together. They really overlap significantly. And my point is, if I give it to you at milestone B, it's going to take you a while to figure out what's going on, all those kind of things. But if you take it past milestone B, 2 years, whatever, then you've bridged that chasm that we talked about, that transition chasm, and that really means that the PEO is going to have to participate in the S&T process, because typically in an S&T developmental environment, we don't do a good job of developing for life cycle costs, okay? We do a good job of developing for performance, how far, how fast, how high, et cetera. But the cost of our systems are all about life cycle sustainment. 75% of that cost gets in there. So that early design is essential. And normally General Gabriel gives this zero maintenance talk, but I'll talk about it right now. Yes, sir. We have got to get to a point where we're designing these aircraft so they're minimal amount of maintenance on a battlefield. We cannot allow ourselves to design for performance, field the system, and try to figure out how to maintain it. If we don't understand the maintenance strategy that we're going forward with the day we start designing the system, we're broke. Okay, and if we think it's a 3-level maintenance system we have today, we're probably broke. We've got to take advantage of all of the Amazon, Walmart, you name it, techniques, processes, pieces to be able to do those kinds of things. We can design an aircraft that does not have TBOs. It's going to cost a little more in ground testing and those kind of things to get us there, but we can do that. But we're not going to do it if we don't ask the companies to do it in the requests, okay? If we just tell them to build an aircraft that's going to go this far, this far, this far, they're going to do it the way they know how to do it, the way they've been doing it for the last 30 years. And we're going to wind up with a system that is not as sustainable, not as low cost as it could be, not as carefree from a maintainer's perspective.
There is very fertile ground there, and there's a lot of that Amazon stuff that we actually know how to put into the vehicle and are ready to, given the right requirements.
And what we do traditionally is we trade those off early when budgets get tight, and as Bill said, it's critical that you fight and maintain those. And the other thing is that you talked about is getting the PMs involved early. Well, we've got these artificial things of when you can staff and resource a PM. That's what fundamentally needs to change to be able to maintain that transition, so you're not throwing something over to transom to somebody else to maintain, to allow that integration as you
Our processes have demarcations, our funding has demarcations, the thought process that we do for sustainment have demarcations. We've got to stop that stuff, and we've got to get down the road together.
Okay. This one kind of, next question, I'll throw this to the panel. Let somebody jump on it, whichever wants to jump on this hand grenade. It kind of follows on with our autonomy discussion. This is a little bit different thought of autonomy, how do we get to one human controlling many different UAS so no one is heads down in the cockpit? That's a multi-autonomy. Go for it.
I'll give it a start. When we've been doing the trades for that ARA aircraft, notionally out there, 4 UAVs, one's doing EW, one's Signet, one cyber, one weapons effects. You can automate the heck out of all of those 4 assets, and the workload is still too high for 2 people in the ARA aircraft. They're flying NOE, dark, stormy night, and formation. You know, they're loaded to the gills. Where we see a huge effect is automating the platform that they're in, making that, you know, we've been calling it the optimally piloted vehicle. Take the workload of the thing they're in, that's probably a little, again, further from the threat, and drive that to near zero. They're in a platform that's doing the NOE ingress, dark, stormy night, collision avoidance, formation flight, all of that, and it frees up their brains to be controlling those 4 assets. And it's fun when you look at that, you really reimagine what a future cockpit is, because it has you start staring at all of the stuff we've been looking at for 50 or 60 years and saying, wow, if you're at that level of autonomy in the core vehicle, do I really need that? Yeah, no. Do I need that? No. A whole bunch of stuff starts to go away, and it frees up space and mental brain power for those 2 previously, you know, operator stick shakers to be tacticians, and to the Colonel's point, work on that speeded decision making, use their operational curiosity, be tacticians on the battlefield instead of you know, shaking the sticks.
Yeah, I think the only thing to add there is if you get to the mission level autonomy, and then you start to build a reliable system, and that system becomes trusted, then the operators don't have to worry about that platform is going to be where it needs to be when it needs to be there. They start to trust that it will be there, that it's going to have that capability. And then as that trust evolves, then they're going to turn their attention away from managing that unmanned platform and only engaging it when it's there. That loyal wingman, so to say, he's there at all times. And that's going to take time. But ultimately, you know, if you look at using the analogy of cars again, you know, back in the 20s, steam gauges everywhere. You no longer have any of that information. You have an idiot light on your car. It says you need to take your engine to go get it looked at. You don't have temperature gauges and oil gauges and all the pressure sensors and those sorts of things. So right now we saturate our UAV operators with information that they simply don't need right now. So you peel that away, much like you peel it away from the operator of the manned platform. Those 2 things come together, and then you start to build trust. I think that's really what's going to enable a one-to-many or a you know, master-slave sort of situation.
So that check engine light, I just put a little piece of black tape over it on my car, so I don't have to worry about it.
You can ignore it for a certain amount of time, yeah.
I think what I'd like to go back quickly to the point Dr. Lewis made about this is we tend to think the way we think. And what I mean by that is us old dogs, we're sitting there trying to analyze and put together a program to evaluate all this. And we need to be thinking how these young kids are thinking. When we were testing the Chinook cockpit years ago, where people were saying it's too complex, I said, you're thinking in terms of the way we think. Go down to the arcade and get that kid out of the mall and let him test it and let him see how he's thinking about it. They think about things fundamentally, and their acceptance is much different. So that's a challenge that we have to be objective of thinking about where they are mentally as opposed to where we old Geritol guys are. Go ahead, Bill.
It's not a cockpit, it's a battle station. Stop thinking about it like a cockpit. If you touch the flight controls, you're probably wrong. I know all you aviators out there looking at me like I'm some kind of weirdo. Trust me, I've been there before. We've got to stop thinking about it like it was. We have to start thinking about it how it needs to be. So, mind warp.
So we are. I mean, and I think Dr. Lewis is saying that. So we're something we refer to as the scalable control interface, right? It's, you know, Wayne gave an example. If you could purpose an OSRVT to give a set of, authorities to a soldier on the ground to operate an unmanned system that could be operated from a cockpit or from another station. That's exactly what we're trying to do. The other thing I'd add, and going back to the whole point about, what things are we trying to invest in the human? And it was a kind of an epiphany for me when we talked about DVE, and a company came in and showed all their things that DVE could do for the pilots. And I kind of said, well, why would you want to load the pilot up with more things that they could see to manipulate the controls when the system, if you could see it, could do it for you, right? So that's the kind of philosophical differences that we're coming to and say, hey, why would you want to do that? Why would you want to add more tasks to the human when you could off-burden those things? And so that scalable control interface, I think from an ALE perspective, so as you said, when you tier it, there are warfighters all over the battlefield that can make decisions. It's just how can you get those capabilities and that level of control to them?
Okay, next up. How do you buy less? We kind of talked this up a little bit, but let's go a little more details, one from the group. How do you buy less total Army requirement and yet maintain interoperability? How far back can you maintain interoperability before you need a new thing? What is the impact in buying less to cost with industry? I think we touched on that a little bit, but anybody want to throw some more thoughts on it?
I'm not sure if this is going to directly answer the question, but it aligns up with some of the other conversations we have. I think you have to be careful whether it's open systems, when you talk about acquiring and owning the IP, that you draw the box around what you want and why you want it strategically and surgically. If you make that box too big, you're going to pay for stuff that you don't want. So is it really the comms link that is going to enable the interoperability? Draw the box around that, not necessarily around the whole platform, around the computing environment on the ground. If it's, sometimes we're over prescriptive in what standards we want to comply with, and those standards then spiral themselves, and you have private messages within those standards. Why not have a system that can speak multiple standards at the same time? So whether it's STANIC 4586, and then maybe you have a new standard on a multi-domain platform that's coming around, 4817, and then there's commercial standards. So start with the architecture that can speak many languages, not a system that can only speak one and then force everyone to speak that language. It gets into how you draw your boundaries in a systems perspective that will drive your costs.
And I think that's a great point. How you design that in your interfaces, where you partition, where you don't, that drives qualification. That's all of the technical sides of it. But then we still got to think in terms of General Gaylor and General Gabriel's aspects. How do they train and sustain mixed fleets, and how do you maintain the configuration, the differences? I mean, just think about the L model and the M model Black Hawk, and that's two different training systems, if you will. It's got to be maintained. So you introduce 5 or 6 different capabilities. You got to be prepared to train that. So anybody else want to jump ahead?
Sure. I mean, and I agree with, what Wayne's points were. And, I would also add that this is part of the dialogue with industry as we talk both open systems and how we would flow out requirements. And when I say requirements, I'm really talking about from the procurement perspective that may have a 5-year cycle time or a 7-year cycle time, because we're not going to go in for, let's say, a 4,000 BOIP. We're not going to go all in to buy everything to kit out every aircraft that we have right now. But to do that, and it is a shift, I'll go back to what Dr. Lewis said, which is, starting with kind of the smaller bounded solutions where we can do something and then how that flows forward. So I'll give you an example, and Colonel von Eschenbach can join in, is aircraft survivability. Right? We understand on aircraft survivability that we are going to have to spiral based on where the threat is. It makes no sense to go in and do a 15-year procurement of a system. So now, within the airframe, how do I design an A-kit as well as the processing on board the aircraft that would allow me to change out a detect capability or a defeat capability as needed based on threat evolution, and make sure that it interfaces to the platform, whether or not it's a future platform or if it is a current platform. And so if you look at doing that, then you say, okay, each platform has a certain different protocol associated with it. whether it's Ethernet or 1553 or whatever I want to use that's on there, there are ways that we can do that, and we can essentially own those interfaces and work with industry on how we host on that area in that box and then be able to spiral very quickly with an aircraft survivability solution. And that works for current and that works for future. And it gets us, I'll use the term that was said earlier, reps, right? It gets us acquisition reps at how to do this and start small, and then as we continue to grow forward. And I'll give you just another example of that on something that we're doing right now where we have an ASE B-kit emulator. So many of the aircraft may not have a B-kit that is on it when it's out training, but we recognize that training is critical as it goes on. So how can we put a B-kit on if we don't want to fill the fleet with those B-kits? So we have developed an application in conjunction with PEO IWS that's going to be hosted on all of the platforms. The same application hosted on Apache, Black Hawk, and Chinook that will allow crews to go out even if they don't have a B-kit on and actually train as if they had a B-kit on. Now, again, that's very small, but that is a start where you take one application and then interface it across multiple different platforms, and you also save the NRE cost associated with that development of one application as you did it. So there is certainly opportunity in what we learn out of that and then how we grow that as we move to the future.
Just to maybe expand, take a slightly different tack from the question, the interoperability reminded me of General Thurman's statement to the Marines that gave us all a chuckle as they arrived in Korea, that he was going to exercise some control over their priorities. Is in the crawl, walk, run of the teaming evolution, when will FVL aircraft seamlessly exchange data with that Marine F-35B that's got its full EW suite, very sophisticated radar, SIGINT capability? When are they going to be handing off data and acting as teammates, with the FVL asset owning the mud and the fighter asset owning the blue sky, and them collaborating on how to break that IADS environment, who takes the shot, who does the sensing, right? That's a level of teaming that holds tremendous promise. We're not there yet. We could probably do it technically. We're probably not there, socially yet. But it's a tremendous vision and opportunity going forward. That'll be the run phase of teaming.
Okay. Next one up, this one's just been titled Advanced Teaming. What do you see as the key attributes of the advanced team? What will it do? Platform mix, performance, attributable team size. I think that's somewhat situational dependent, but Tom, is a seated, what kind of envision would you have for something like that?
So I'll try to answer this question like this, and I think Dr. Lewis kind of kicked it off and I know we've spent a lot of time focusing on our ideas of material solutions and technologies here, but along the same time that we're thinking about those, we're thinking about how do you organize, how do you conceptually employ those systems, because we can't lose sight of why we're doing this. And General Gaylor's comment, the why is we need to regain standoff because we don't have that. So how do you increase your reach? How do you increase your lethality, which inherently increases your survivability protection? So what we see is more of a kind of the first launch of with the most reaches would be air-launched effects, which are smaller but many. And that begins the cycle of that detect, identify, locate, report, the action, reaction, counteraction cycle that allows us to have some situational understanding of the enemy, allows the enemy to then operate its radars or do things, and then you now come in with potentially unmanned systems, advanced UAS, which then kind of do some other things with additional lethality, and then you have the opportunity then to have your manned systems come in. And I'll speak to the future of the Apache. So we all talk about IADS. but what's the end state of that? We don't just leave when the IADS gets disintegrated. It's for a purpose. And the purpose is now we have an opportunity to maneuver. We have an opportunity to destroy his long-range fires in order for our ground forces to now maneuver to a position of advantage and then occupy terrain. So, I mean, I think that's the stage of how conceptually we are looking at it. And certainly, you know, as we think about it organizationally, you know, this is not a divisional mission. It can be employed at the division, but this is certainly at echelons above division and then initial stage to defeat A2AD strategy. So, you know, go back to I'll finish and say the speed. You know, the speed of this decision is parallel to the speed of our decision and across the full DOTML of how we're going to do this. And it's stressing our ability as we form a futures command to figure all these things out in time, to have all those things, you know, kind of in line with each other, to what Dr. Lewis said. I mean, we have to work together closer than we ever had to make these things, when they're delivered, to be able to be used in the organization they're going to be used at.
Yeah, I've always been told that if you want a good leadership team, you want to bring a leadership team together that's got a diverse background, you know, different thoughts. You know, if you're all thinking the same, ain't nobody thinking kind of thing. And I think that's true with this team. You can't have a team of vehicles that are all the same, right? Because that means you're optimized for something, but you're not optimized for everything. So you have to come up with a mix that makes sense. I mean, you'll have a breacher mix, you'll have an offensive mix, you'll have a defensive mix. There will be different aircraft, different vehicles, different systems, if you will, playing different missions throughout that period of time. Are they attritable? Yeah, some of them are. Some of them aren't. I mean, if you have a weapon system that, you know, is, I mean, right now we're looking at trying to get a cruise system off the rail. You know, how do you spin up a cruise motor and get it off the rail? It's a 200-click system. It's probably got something on it that you either are going to terminate in anger, or is going to do something for you in terms of sensing, right? So if it's one of those terminate in anger things, you probably don't want it to come back, right? You're going to get rid of it when it gets out there. If you got a $14 million sensor on the front of it, you might want that sucker to come home. So it really kind of depends on exactly what kinds of things you're going to do. But I do believe that they'll be echeloned. I mean, Corps will have assets, you know, Army, et cetera, down all the way down to the division, all the way down to BCTs. All those systems will have assets, and they won't all be the same. It will be applicable to the organization and to the operation that they're getting ready to perform. But I don't think one size fits all in this case. Over.
Okay. I got more questions than we're going to have time for, so we'll try and buzz through these. This comes from the WUTAG guys. Y'all know what the WUTAG is. There's four of us. I'm the starter. It's the worn out, old, tired ass general group. And Jim, you get the best handwriting award. Okay, on this one. There you go. Tom, I guess this really goes to you, and maybe Bill, to you a little bit. The pace of technology advancements requires accurate assessment of technology. How comfortable is Fort Rucker with the input received from the S&T community? And then how comfortable is industry with the transparency of this process, and what can be done to improve it? So Tom, why don't you start us off on that one?
So I'm very comfortable with our relationship with Amerdeck and the guys in the aviation community. Where it gets a little bit more complicated and where we have work to do, and again, I keep going back to the air launch effects, but I mean, that has 4 capabilities on that potential platform that'll potentially come from 4 different PEOs. You know, you got C3T on a network, you got the air vehicle from aviation, you got a payload from possibly IWS, and then you have, if it's considered a munition, it's missiles in space. So that's where I think, you know, where we can work together better on. I would say too, just from my own, you know, introspectiveness, the capabilities integration has to be worked on better. I guarantee you the fire center is thinking about air launched effects being shot out of a cannon, and we're thinking about it being launched off an aviation platform. we're looking to do the same things, and we're doing it differently, and we're probably doing it redundantly. So there's area to improve, but again, I'll be optimistic in that the opportunities we have in Futures Command to kind of start to set and really, I would tell you, integrate the CFTs and the capabilities of those systems much better is really where we're going to win to do that.
Well, I'll tell you, I mean, I think, Tom, we have, up until about a year ago, I think we were linked real closely, right? And then this CFT thing happened. Damn. Bull in China shop, right? So we have so many people trying to help us come up with answers that it becomes kind of confusing about who's in the front of the formation today. So it becomes a little problematic in that regard, because, I mean, I'll just be honest with you. You know, I'm with General Rugen, I'm with Tom, we're out doing stuff, our teams are off doing their thing, we're trying to keep everybody in the tight formation, all those kind of things, but, I mean, things slip away. I'll just be perfectly honest with you. Sometimes we don't always get it right, and I think it's because of there's so many folks trying to help us in the process of getting down the road. So it becomes a little more difficult. Over.
To almost go full circle in the discussion, in the beginning we talked about kind of a comprehensive simulation environment that would help us model these effects and qualify them, understand how they work together. That can be a great tool for communication, collaboration, industry, and government participation. To do the modeling collaboratively, do the OA to understand, you know, what really works and what doesn't.
Okay.
And I just did, because this goes back to, you know, a point that Dr. Lewis made where he talked about boundaries within the acquisition system, and then Colonel von Eschenbach brought up, you know, PEOs, 4 PEOs being involved into the delivery of a capability, and it shows the complexity of the capabilities that we have right now. And so, you know, that is the biggest focus, and as General Todd looks at this and talks about integration, it's not just integration within the PEO, it's integration across the acquisition domain, and how we are interfacing to each one of these PEOs, how we work collaboratively, and we are working left of milestone B. So, you know, none of us look at the world through the 5000.02 framework in a sense. We understand what statute is, and we understand what we need to go do. But as Dr. Lewis and I have talked many times, is where his boundary ends and ours begins needs to actually have a huge overlap in it so that we can properly assess the technical maturity as we come through, make a determination of the abilities that have to be added onto it, affordability, producibility, survivability, maintainability, cost that out, and then be able to put it into a program that industry can go out and execute, right? Because even on the S&T side, we understand the dollars are still relatively small, and it really is when you get into the procurement side that we start talking about the big billions, and we want to have that laid flat before we get into it. But we do understand the absolute need to have that wide overlap. And the same thing goes on the back end side of it as well, in working with AMCOM, and how we think about the transition to sustainment as soon as we are starting to think about the concepts of what would be flowed out for industry to actually produce.
Just one comments from the audience for once. So one, I think we have to, and we're still wrestling with this, what is the transition to sustainment? So everybody's got a different opinion in this room. Two would be your example of the 4 PEOs working. We got several examples, not for this audience, where who's in charge. So collaboration, working together is interesting, but somebody has to drive it and synchronize it and be in charge, and I think that's where we need to work on. So.
Okay, I think we're going, one last question. I apologize up front if we didn't get to your questions. I got one more here, and Wayne, we'll start out with you, and I think everybody else will want to jump on this one. Can you comment on industry's perspective on the timeline and acquisition approach that has been laid out for the future UAS and advanced teaming initiatives?
So I think we all recognize that the timeline is long, and it's gonna take time and effort to develop the material solutions for the objective system that everybody wants. I would contend that there's more we can do today with the assets we have available to continue to inform those requirements, to learn how we are going to train and fight these systems together, that will make that end objective even a better solution. So there has to be experimentations and exercises that are not graded events where industry can collaborate with the defense team and experiment and identify and fail, and it's okay to fail, and to learn those lessons and inject them back into the stream. So I'd offer that as an observation.
Anybody else?
Yeah, I would just add, just like the social or psychological discussion of how much can a warfighter accept in terms of change, spiraling in capability, little bits at a time, is very attractive, particularly in this area.
Let me just hit this one. The timeline's going to be a while. However, there's several wins at Echelon. In other words, what I'm saying is, we're not going to develop a vehicle that has every capability that's going to be resident in 15 years, right? Some of the things haven't even matured yet. So we have to take a look at this. Now, this is really the first time that we've taken a good S&T look at the kinds of things that we want to develop for our unmanned vehicles. I mean, if you look at a Shadow and you look at some of those systems, I mean, those are plywood and dope put together. I mean, those are garage developed systems that we adopted because we had to, right? This is the first opportunity we've had to take a good S&T look at what is achievable, in configuration, what is achievable in payload, what is achievable in autonomy and AI and all of those things, and to get it right, at least close to right, mitigate a lot of the risk going in the door. Okay, if we abandon that approach and we go pick brand X that's sitting on a shelf right now, you're getting brand X that was developed, 15 years ago. That's what you're getting. That's probably not the answer that you want 5, 10, 20 years from now. It's going to take a while, but take the wins as they come with the vehicle, with the payloads, with the systems, with the capabilities.
To build on that, when you do the trades of what can team with FVL, the speed, the range, the survivability requirements isn't that incremental plywood and dope built airplane. It can't possibly keep up and contribute as an FVL companion.
And there's going to be times where buying the plywood and dope is the right answer. But what we need is a process, and I'm hoping that all of this new organization, this discussion, will allow us to think futuristically, like Dr. Lewis is talking about, and planning for that growth, planning for that spiral development, those obsolescence upgrades, so that we don't end up throwing away. I mean, let's face it, we're looking at the Chinook being the 100-year airplane. We need things that we can continue to add and modify and modernize and upgrade, but because we can't afford to be buying new platforms. Well, lastly, I'll close this out and just say, once again, on behalf of AUSA, thank you, gentlemen, for taking the time to do this. This exchange with industry is what we're all about, and I'm sure John Swan will take over here and add to it, but on my personal thanks for your support.
Let's give him a hand, folks. Thank you.